Hi guys, today I will talk to you about UDS count and being an automotive software tester. I'll explain a little bit more about what you need. It's a job that's normally in ZF Plzen. It's called a software tester, but you're working for the automotive industry, and what you're testing is the software of the ECU, that's electronic control unit. Some call it TCU, transmission control unit. It's the same thing, it makes no difference whatsoever. So I'll give you a little bit of the basics and hope you understand, because this is an interesting profession. It's not very hard, well, except for some tasks, and you will learn a little more about how to do it. This little guy says hi, and let's start. As you can see here, I have the CAN and the format of the CAN. Remember, the CAN is a protocol. It has only 2 wires and terminating resistors. It's 120 ohms terminating resistors. But today we will review what you need to do and how to send information to the ECU so you can receive some information back. You use various tools like IBM DOS and other things. Let's say IBM DOS is a versioning software similar to GitHub. It's used in order to make tests and then make changes to these tests just in case something is necessary, but the old versions are still kept and saved somewhere. Also, your team leader and so on can check what you have been doing, what changes you have been making, and so on. You see the CAN format on my display. We will start the CAN ID, and the protocol or control info is something that I will skip and continue with the next few bytes, which are the service identifier, subfunction, and data. Let's go. First, UDS has various service identifiers depending on which service you want to use. Mostly the most common one used is ReadDataByIdentifier or 0x22. That means that whenever you're making tests, you will be sending to the ECU 0x22 ReadDataByIdentifier. Then of course we have the function identifier, which is the next byte. In this example we'll take something like 0x02, and the whole packet becomes 0x22 0x02, which is the request. This is a request which you're sending to the TCU or ECU, and after that the ECU will receive it, check if it supports this function, and tell you what is stored in the memory, of course if you have access to it. There are a lot of other things that you need to learn, but we'll start from here. For example, 0x02 is read if the ignition is on or off, and so on. Read the ignition. When we send the request, that means we sent 0x22 0x02, and after that the ECU receives it, checks if it supports this function, and returns to us. Positive response, that means that what will be returned, the response will be 0x62, because the positive response is always the request plus 40. That means 0x22 plus 40 equals 0x62. A positive response, the function is supported, the memory will be read, and the information returned. Therefore the response becomes 0x62, then 0x02 as the subfunction or the command that you want to check if the ECU supports it, and so on. In this case the ignition, and then 0x01. That means we have 3 bytes now that are returned. The third byte is the data. That means the actual state of the ECU, of the ignition, the current state of the ignition. So if the ignition is on, you will receive 0x62, 0x02, and 0x01. That means ignition is on. If the ignition is off, of course, you will receive 0x62, 0x02, and then 0x00. It's not very hard. The third byte is the identifier for data. That means it shows you the state of the ignition. This is very important, as you need to work with the ignition a lot. Engine on, ignition off, and various things need to be set up in order to perform some tests. And this is pretty much it. We've just checked if the variable is working correctly, if the ECU software is working correctly, and it returned what we expected, in this case the state of the ignition. Thanks for watching, guys.